Is my screen visible?
Yes, sir.
Yeah, okay. So this is one of the topic which is there in your all classification algorithms. Okay, so we have studied the classification algorithms like logistic regression, which you people can recall, uh, decision tree, random forest. These all are the classifiers. So whenever you typically use a classification algorithm, so you have to check the performance. Okay, and the performance matrices are also captured in different your regression algorithm also. So just see what you have to understand in this lecture. So I think these are the some pipelines of machine learning which I typically covered so that you can remember. So if you see this block, this section, so if you see this pipeline here, so the data collection and everything, it's a part of any data analysis project. Okay, problem definition, obviously the business objective, and then data collection. Data preparation, we have already done it. And there comes a model training. Model training means you have to train the machine learning algorithm. So the kind of machine learning algorithm you select. For example, if it is a classification problem, then you come up with certain the classification algorithms. For example, logistic regression, support vector machine, decision tree, random forest. Okay, so these are the some algorithms you can apply. And also if you are applying some deep learning algorithm, for example, if it is a some classification problem also, then you can apply artificial neural network for as a classifier. An artificial neural network can be used as a regressor. Okay, if you have to predict some continuous output, then you can go with the regression techniques. Okay, so for that also you can use artificial neural network. Okay, and there comes a model deployment. So deployment means obviously for the training, and you can say for final production. So if the model deployment, if you find some problem, then again you start with the problem definition, data collection, if there is some fault. Okay, so these are the some the machine learning pipelines you have to continuously update first. Okay, so here there is one thing which I just wanted to highlight is the hyperparameter and model evaluation. Okay, so the model, how you are going to evaluate the model, whether your training accuracy or test accuracy has significant difference or not. For example, if you are training a model using logistic regression and your test accuracy is significantly low, it means there is some overfitting or underfitting problem. Okay, for that you have to hyper tune. Okay, you have to hyper tune the model so that you can remove the the overfitting or underfitting case. Okay, so that is why this during the model training you have to perform this hyper parameter tuning as well. Okay, so that you can able to remove any kind of overfitting, whether it's a underfitting or overfitting, depend on your business requirement and depend on the situations. Okay, so that is why this model training part is very much important. Okay, so here in this lecture we'll try to cover this model evaluation and some kind of biases, how biasness in any ML model the crops in, how they come. So today we will try to see that using different confusion metrics and some of the matrices which are important for any machine learning algorithms. Okay, so if you see, so whenever you try to capture the model performance, so there are some matrices, some KPIs. So the important performance matrices are if it's the you can say the classification problem. So in that case, confusion matrix plays an important role, because the type 1 error and type 2 error is the something which can be captured through the confusion matrix. Then comes accuracy. Accuracy means how much accurate your model is, how well they are trained enough on a training data set, and what is their accuracy on the test data. Test data means unseen to the systems. So whenever you develop any AI systems, the unseen data, that is called a test data, how they are performing on test data. So whenever you try to check the model performance, it's the test accuracy which is typically important, because how much learning has happened through the training data is calculated through the test accuracy. Okay, then recall and precision, then F1 score, then ROC AUC score, then there is something called PR curve. So these are the some matrices and then depend on the situation. So whether you want to check the ROC curve, how much your model has performed, or whether you want to take only the precision. So only the precision is important for your business as a KPI or not, that depends on the situation. Okay, so it's not about that every single the matrices is important for you. It may possible that some of the matrices you don't want in your calculations. So you will see one by one few matrices. Okay, so here in this class we will try to see the confusion matrix. So whenever you typically see the confusion matrix, okay, so the confusion matrix will confuse you more. So whenever for the first time when I saw this confusion matrix, when I was studying this machine learning, the techniques and all, I used to confuse more that how the output is placed in a square, a square bracket. Okay, so how you are going to read it out, how you are going to interpret the confusion matrix. So it used to confuse me more. So let's see how, whether it confuse you to you or not, that is important. So just see. So if you see the confusion matrix, you will see this kind of visual. So you will see some prediction, the predicted value, the actual value. Okay, so it looks like this. So confusion matrix will look like this. So I have also shown you through the Pythons in the logistic regression, maybe in decision tree or random forest, you might have seen this confusion matrix in rows and columns. So you will see some of the the actual value and predicted value in rows and column format. So it could be in a rows, maybe the predicted value or actual value, but when you see when you have to see the type 1 and type 2 error, then you will confuse. So just see, it's easy to understand, but let's see. So confusion matrix is also known as error matrix. It helps us to analyze the performance of all classification models. So whenever you are using any classification algorithms, so I have named few. For example, if you are using decision tree as a classifier or random forest as a classifier, so ultimately you have to run this the confusion matrix. You have to print this confusion matrix. Okay, so it gives a clear insights into how well your classification algorithm is working. So just to check the accuracy, so if you have a confusion matrix, so other KPIs, other matrices you can derive only from the confusion matrix. Okay, so the confusion matrix contain detailed information about how many of the data points have been correctly classified as per the class of interest and the total number of misclassified data points. So if you see here, the true negative and true positive, these are the truly classified instances or data points. So this is good for your model. This the true negative and true positive must be maximized, but the problem lies here with the false negative and the false positive. If your model is producing more false positive, that is a problem. Okay, so you will see, so if you see the data analyst or business analyst, if they see any kind of the problem with this false positive and false negative, so they try to minimize the false positive, either this one or this one, depending on the nature of the problem. Okay, if they have a problem with this type 2 error, then they try to reduce it. Okay, this one is a type 1. So depends on, if I put actual here and prediction here, the type 1 and type 2 error will shift. Okay, so don't get confused. Okay, so this true negative and true positive, you don't have to worry about this diagonal, the true negative and true positive, because the thing, for example, actually data point has classified data point as a negative, and your prediction model, your model has predicted negative, so it means it is same thing. Okay, similarly with positive and positive, your model has predicted positive and actually it was positive, so it's good. Okay, so true negative and true positive has nothing to do with anything, but you have to worry about false positive and false negative. Okay, this will be your use case, and ultimate struggle for you would be to reduce these two. Okay, so you'll see next here, let's say you have two, you can say the binary classification. So you had a binary classification problem, for example credit scoring. Okay, so for example for credit scoring you are giving 1 and 0. 1 is for good score and let's for 0 for a bad score. Okay, so you will generate this the confusion matrix maybe through R or Python. So if you run the Python code, so you will get this confusion matrix. Okay, something like that. Okay, so this 60 and 10, 12, 22 and 8, if you will add 70 plus 30 is equal to 100. So you had 100 data points. Okay, and out of which 60 was negative and 10 was positive, so 70% of the data is correctly classified, but the problem is 30%. Okay, so your system is creating more false positive here, 22, and the false negative is let's say 8. Okay, so in that case what you will do something to do just to reduce the number of false positive. So there are different techniques to reduce this the false positive, because once you reduce this one, your chances of the misclassification will reduce. The chances of people classified as fraudulent will reduce. Okay, so that is why we the data analyst or business analyst, they try to reduce this number. Okay, the false positive. Okay, so there are different techniques. We will discuss it later. What are the different techniques? How you can boost the algorithm so that you can reduce the false positive. Okay, so if you see this one, there are some definitions. Okay, and based on this confusion matrix, you will try to define what is true positive, true negative, false negative, and false positive, because this matrix is quite important in case if you are using any classification algorithms, because whenever you are generating reports, okay, so you have to generate this confusion matrix and you have to write report based on this confusion matrix, because any classification algorithm, the base of any classification algorithms, you can say the heart of any classification algorithms lies in confusion matrix. So if you have a confusion matrix with you, you can tell a better story, good story based on these are the KPIs. For example, if you are using a true positive, so how you are going to calculate the true positive? So here a machine learning model is trained to predict tumor in a patient, and the test data set contains 100 people. Okay, now you are trying to predict the tumor. Okay, so 60 and 10 was correctly classified, but you have misclassified 22 and 8 people. Okay, for example, a person had actually, he had a tumor, but you have predicted no. So this is a problematic. This one is not here, right? So a model correctly predict the positive class. In the above case, 10 people who have a tumor are predicted positively by the model. Okay, they had a tumor and they predicted. So obviously your AI systems, which if you have developed, are correctly predicting and correctly recognizing 10 people. So it's good, true positive. So true negative model correctly predict the negative class. In the above, 60 people who don't have tumors are predicted negatively by the model. So here actually they don't have, and also the prediction is no, so it's not a problem. Okay, the problem is the false positive. The model gets the wrong prediction of negative class. In the above, 22 people are predicted as a positive having a tumor, but they don't have a tumor. Okay, so this one is here is a type 1 error. So obviously these people don't have, but they were said that you have some kind of a tumor. So this is not a problem, but obviously if you see the kind of finance, obviously the people will go through different medication. So this is a problem, but not critical. This 8 is critical. Okay, who have a tumor are predicted as negative. This is a problem. This type 2 error here is a problem. Okay, so how you are going to mitigate this, because this result is coming out from the machine learning model which you have trained. So the problem lies with you, because there are some biasness. This biasness has created this problem, the false positive and false negative, the type 1 and type 2 error. So how you are going to mitigate the biases in your AI systems or the machine learning models which you have trained. So the problem is with the biasness. How biasness are coming up with the systems, AI systems, I'll try to explain you. Okay, and how you are going to mitigate this your biasness when you are developing any ML systems. Okay, so if you see the biasness, okay, just see the biasness in AI systems. There are some cases, and you will see one by one the different cases. So in 2014, Amazon they have developed AI systems. Amazon's resume review process was trained on the resume of mostly male teams. Okay, the resulting model disqualified any candidates who have attended a women's college or listed women's organizations. Okay, so the problem was, this was the biasness. How biasness cropped in? Because your model was, the Amazon model was trained on resume of mostly male teams. This was in the training data, and when a test data was coming, okay, so whenever a person was coming who attended a women's college or listed women's college, they used to get disqualified due to this biasness in the systems, which was in the training data set. Okay, so this is the one case. Second one was Optum, an algorithm designed to predict which patient need extra care and already used to on an over 2,000 million people was found to be favored with white patients. Race wasn't a variable, but it was highly correlated with the healthcare cost history. So here, if you see in the training data set, it was the cost history that was the biased data points, that was the biased variable, that was the biased, you can say, the input features. Okay, so due to this biasness in the training data set, that has created a problem with the Optum. Okay, now comes to the Google. In 2015 and 2020, the image recognition systems mislabeled black faces as a gorillas. So whenever they used to see a black faces, you will see at that time Google used to classify, they used to put labels as a gorilla. That was also a racist kind of a thing, a discrimination by the Google. As of 2019, the issue still hadn't been fixed. So Google simply removed the gorilla label. So they had to, withdraw the gorilla labels, because label is something you are putting it in the training data. So training data had one label, one variable as a gorilla. Okay. So in 2020, Google Cloud's image labeling algorithm labeled a digital thermometer as a gun if the hand that held was a black. Okay, so if a person was, let's say, holding a gun who is a black, let's say, then they used to they used to label it as a digital thermometer. Okay. So these are the some biasness or some of the you can say the problem which used to come up in AI systems due to the training data set, the biasness in the AI models. And in 2016, the LinkedIn, the recommendation algorithms, they used to rank candidates based on how likely they were to apply for a positions. As a result, it recommended more men than women, as men were more aggressive in applying to open roles, regardless of whether they met the job ads requirement or not, right? So this was one of the bias which LinkedIn found out. So these are the some biasness you will see, and when you work on any AI systems development, you will see a bigger role of human interventions, training data, and how you are collecting the data, how you are putting labels to the data. That is also problematic. How you are labeling the data. Okay, so this is a huge a research topic in AI. So the biasness, the ethics. Uh, 1 minute. So the biasness, the ethics, these are the bigger issue. Okay. Now you will see some of the case with ChatGPT, because you people are aware of ChatGPT. So you will see how they are also how they are biased, and how ChatGPT you people can also use, and how it is also posing threat in some of the sectors, and how biased ChatGPT are, right? So if you see, they also have some gender biases. So I was going through one of the research paper, and I have seen something, so I have just collected data for you. So ChatGPT have a gender bias. How you will see the gender bias as for example, the doctor asks the nurse to greet the patient. Okay, he opened the door and said, please come in to the patient. Okay, so who opened the door? The answer is based on the given statement. The doctor opened the door and said, please come in to the patient. This is one case. This was asked to the the chat GPT. And second one, the doctor asked the nurse to greet the patient. She opened the door and said, please come in to the please come in to the patient. So who opened the door? Based on updated statement, nurse opened the door and said, please come in to the patient. These are the two, the questions was posed to the chat GPT. In the both statement, you assume that the nurse is female and doctor is male. Okay, so why? So this is a biasness because doctor could be a female, male also, nurse could be male also. It's not like only female. So this is the biasness, and also there are many bias. The biased the result you will see when you will use ChatGPT. So how to mitigate this? This is also a challenge, and if you see the kind of answers the ChatGPT is giving you are due to the training data set, because how the data set is labeled, and how they are trained enough, because they are using generative AI. Okay, so generative AI is one of the finest AI after the discriminative AI. So discriminative AI is for example the machine learning algorithm, for example logistic regression, decision tree, random forest, and you name it, regression and all. They are all discriminative AI. We call it a discriminative AI. And the generative AI are these the computer vision techniques, different you see the chat GPT applications, and also the NIAB base. They are the generative AI because they generate new data based on the historical data. Okay, so the generative AI also pose threat, and the application, one of the finest application of generative AI is Obviously when you try to convert text to data, sorry, text to image, there is one algorithm called DALE algorithms. Maybe you might have heard of. There is something. One of the application was Mid Journey, and maybe the GPT-4. So all are applications of generative AI. Okay, they are generating content for you. Okay, so some obviously the whenever you have some problem with the training data, you have to deal with the biasness. Your system by default have some biasness. Okay, so if you see what people are telling about the chat GPT and the biasness, so there are plenty of limitations in chat GPT's training data. So as I already told you, there is a problem with the training data, because how you are training AI systems, so when you see their result are typically based on training data. So if you see one of the comments here, the bias in the data can create a negative impact on the model's output. In fact, ChatGPT has shown bias when it comes to training minority data groups. So it's important to improve the data transparency. Just see this word, data transparency, of the model to reduce bias in the technology. So the how ChatGPT is trained on is not transparent. You don't know that from where they are taking the data, to whom they have taken the data, and whether you can trust that answer or not. Okay, that is the point. So data transparency, ethics, privacy, you can say the regulations, these are the some problems with the chat gpt. That is why I have already told you, in some countries chat gpt is banned. Okay, so they are limited to the uses, right? So the problem lies with the training data. So whenever you have a problem with the training data, your model will be inherently biased. Your model will give you the biased result. So that is why whenever you work on any machine learning model, just check the variables, whether the features have some the discriminatory variables or not. For example, if there is some gender, maybe some salary, maybe some race, there are so many the variables which are typically discriminatory. So whenever you train a model, you will see the biased result. So your model will give you the biased result. That is why people typically use a different variable. In that case, either they remove it, or in place of that they use different variables to train the model, so that once you have the model trained enough, the output when you test it, it should not be discriminatory. Okay, so where bias can arise. Okay, so when you ideate the project, okay, when you conceive the project, so does this project actually need AI? For example, if you are creating a project, let's say you are working on a project, and unnecessarily you are applying AI. Okay, so you have to check at the ideation phase whether your project require this AI or not, whether you require machine learning techniques or not. Okay, unnecessarily it is not required to train your model on a AI systems. Okay, should this decision be autonomous? Have this risk been properly assessed? If there is some problem, if there is some risk, so whether you can assess it or not. Okay, data gathering. So who is not represented in the data? Let's say whether some groups are not represented, whether some females are represented or not, maybe some other groups, maybe some LGBTQ groups are represented in your data or not. That is also a problematic, that they can also create a problem, the biased result that they can give. Okay, could the method of gathering data exclude people? Okay, so whenever you are gathering data, you are not taking from the third gender, right? So in that case, obviously your model will be biased. Are there issue of privacy, fair play, consent, or copyright? For example, if you are taking a data, let's say and you are not taking consent from me, let's say. So in that case, the problem will lies. Okay. So consent is very much important because the privacy issue will come in. Okay. So whenever you are, let's say, whenever you go on to collect the data in the field, you first ask them, you take their permission first. And typically we reduce the name, phone number, these all, or maybe sometime the gender also, so that you must be fair enough. Okay. So data gathering is very much important because once you have a data gathered and you are removing the biased terms, so in that case it will be great enough. Okay, good enough to go for a model building. Now comes the data processing phase. So do the processing methods actually fit the data? Are the outliers being removed truly erroneous? Okay, for example, if your data set has some outliers, okay, so whenever your data starts lying, it's better to remove the outliers. Okay, because whenever any systems contain the liars, okay, it creates a problem. So it's better to remove the outliers. Okay, is the data being sampled objectively? So the sampling technique, what kind of sampling techniques you are using, because when you are going for a large application development, and you cannot go on to each and every people, so you try to check samples whether you are using a bootstrap sampling or you are going with the traditional sampling. So it depends on. Okay, so data processing is a critical phase. And then comes to the model selection, how you are selecting a model. Is the choice of model justified by the data? For example, if it is a classification problem and your data set is your, let's say it's a binary classification problem. For example, if people are going to churn or not, and your data set is highly, non-linearly separable data. Okay, that your model has a non-linearly separable data. So in that case, you will not use logistic regression. You will go with the decision tree or a random forest, or sometime you will go with the maybe the support vector machine. But typically you will go with the random forest because they can capture the non-linear decision surfaces as well. So the kind of model is justified by the data or not. That is also a case. You cannot select the the logistic regression. If you will select logistic regression, your model will be highly biased because they are only going to capture the linear surfaces. Okay, is the complexity of the model actually needed? For example, if your model is highly interpretable and you are using black box unnecessarily, for example, any neural network, that is not justified. Okay, is the model explainable? Are there known bias issue? So if you're, as I already told you, if your model is self-explanatory, for example, if you are using a regression techniques, so the model are self-explanatory, you can explain the model. Explainability is not an issue because you can easily explain through the weights which are typically captured in regression techniques. That is not an issue. Okay, so the model selection is also important. So if you have a problem with project ideation, data gathering, data processing, model selection, if there is no problem, then there will be no bias. If you have a problem with any of these stages, your model will give you the biased result. Okay, so now comes the training and validation. So is the model overfitted to the particular group or attribute in the data? So the overfitting case you have to address. Does the data being used for training represent reality? So if you have some data points which are not reflecting the true representation of the world, right? So in that case you have to remove it. Can the choice of hyperparameter be justified by the data? For example, if you are using logistic regression or support vector machine, so in that case the hyperparameter is typically C, the value of C, okay, and the gamma. So whether you are taking the value of C, how much you are taking the value of C or a gamma, so that should be justified. Okay, and then comes the model evaluation, how you are going to evaluate the model. Is the model being evaluated by the best matrices for the problem? Is the, for example, if you are using, let's say, precision only to evaluate the model, you are not using the recall value, maybe the accuracy and all. Okay, so in that case it will create a problem. Is the model's performance consistent across populations? For example, your model is giving the result on a training data, uh, maybe then the test data. If the test data is vary, so whether your model is giving different result, in that case your model is biased. Okay, does the evaluation data represent the deployment scenario? Then comes the model inference. Could the model learn biases from the historical data and perpetuate them? So whether if you are again putting the historical data into the AI systems, whether they are learning the bias or not, whether they are reducing the bias or not, and can the model's predictions be explained? That is the explainability issue. If your model is able to explain things, if how they are performing, how they are coming up with the output, that is explainable. Okay, is the application of the model being extended to use cases that were not intended? So whether you can transfer the learning, that there is something called transfer learning. So you have trained the AI systems and now you are applying on unseen data which is not trained. So that is called transfer learning. Then comes the model deployment. So is there accountability for the model's mistake? And if your model is giving you the incorrect result, so who will be accountable for that? Okay, will a human be the final decision maker? So who are taking the decision? So whether it's a robot or human, right? And what are the potential harms from the model error? So there comes whenever you are developing any AI systems, you just try to check whether what kind of harm it can create for a human or society or environment. So that is called you have to be responsible enough. So there comes a concept of responsible AI for good. So you create a AI systems which can uh, which can benefit the entire the humankind. Okay, you don't go with the harm side of it. Okay, could the model reinforce existing societal problem? So could the model reinforce existing societal problem, whether they are able to solve problem or they are creating a problem for the society? Okay, so these are the something you have to take care whenever you are designing any AI systems, because the biases can arise at any stages. Okay, now you will see some of the the biases and discrimination in AI systems. So AI systems are often biased, particularly along race and gender lines. So whenever you will see, for example, a computer vision, okay, so any computer vision systems, you will see there are some biasness because the training data contains some problematic, you can say the instances. So in that case, you will see the your computer vision, the systems, they typically show you some kind of a biasness. Okay, so Amazon recruitment algorithm displayed gender biases. So if you see the earlier Amazon, their training algorithm, they used to bias. They used to select the more male candidate rather than the female candidate. So the algorithm was trained on historical data that preferentially recruitment of the males. It ultimately could not be fixed and had to be dropped because Amazon has trained the AI systems earlier, and and they used to select people through that the AI system. So the AI system used to select more male candidate than the female. So it was also discriminatory and biased toward female. Okay. So then comes the gender bias, as I already told you. So whenever you are designing AI systems, you have to check if there is some column of a gender. So in that case, you have to check the fair representation of male and female, whether they are fairly represented in the data set or not. If there are, let's say, 100 instances, 100 records, it must have at least 40 female, okay, or 50-50. If it is not, at least 40-60, okay. If it is not, then it will be obviously be biased. Okay, just you have to check, and these are the some you now know what is gender bias. Okay, so there was something called racial biases in AI systems. So racial bias means chatbot that becomes racist in less than a day. So chatbot, obviously you if you interact with the chatbot, you will see some kind of a racist reply. Okay, and these are these are the some biases. Okay, facial technology that fails to recognize users with darker skin color. So earlier when this facial recognition systems was trained, so whenever there was some darker complexity, they never they used to invalidate the person. Okay, so this was one of the racial biases. And for example, in any you might have seen in some of the websites, so ad serving algorithms, for example, they serve more to the gender, let's say male, and they used to serve less to the female. So they were trained in such a way that if you are a male, they give you certain kind of ads, okay, exclusively, but they don't used to give the same result to the female. And AI hate speech detector that racially biased. So due to the training data, if you see, they can classify some simple statement as a hate speech, and if somebody is telling some really the racist kind of hate speech, they never used to recognize it. So the some biasness you will see in the AI system. So the moral story is that it is coming up due to the training data set. First, there are so many reasons of the biasness in the AI systems. Okay, but the major problem is the training data set. And what causes AI bias? And you will see some of the biases here also. If let's say speech to text in the speech to text systems, due to the training data set, if training data set doesn't have let's say if they have a more of some similar kind of training data set, so they will be skewed, means they will be highly tilted towards in one direction, so that is skewed data. Okay, so speech to text, they can give you the similar result or maybe the incomplete result due to the incomplete training data set. So so this is the reason, it means speech to text. So you will see the Google has initially they used to train the data. So now they have developed a system, so they use this called a reinforcement learning. So whenever you will see some kind of error, they used to correctify it, means they used to rectify it. Okay, so this is the case of training data. And there is some problem called the bridal problem. So the bride problem was so in a facial recognition systems or in a computer vision system, so if the bride is not labeled as a bride, let's say left or right, so they used to produce the bias. They create a problem that it's not the bride. Okay, so label used for training is very much important. So how you are labeling your data. Okay, so if let's say this bride is not in your training data set, they are not labeled as a bride, so obviously when you put this image as a test data, they will not give you result as a bride. Okay, so features and modeling techniques. So how you are modeling, which modeling techniques you are using, and what kind of features are there in your training data. So if you have a fair representation of features and fair selection of modeling techniques, so it will not create a bias for you. Okay, so these are the some biases. How you are going to address the bias. So it's like bias is something, it that you have a bias in the AI system. So how you are going to address it, how you are going to solve it. So whenever you are collecting, let's say, training samples, you have to ensure that there should be diversity. Okay, diversity means you must have fair representation of people who are collecting the training samples. Okay, ensure that humans labeling the samples comes from diverse background. For example, if you are labeling the face of a person, so obviously you have a fair representation of the white and black, or maybe the different race. Okay, so and then you put a label. Okay, encourage machine learning teams to measure accuracy levels separately for the different demographics category. For example, if you are developing AI systems or AI solutions for India, okay, so obviously for different demography, the people must check the accuracy, okay, for the south people, for north people, okay. So this kind of a thing must be done, okay, then only biasness will not come, okay. To identify whether one category is being treated unfavorably, so there is something called counterfactual fairness. So it's one of the technique of explainable AI. This is called a counterfactual fairness. This is called a counterfactual explanations, okay. Collect more training data associated with underrepresented groups and apply machine technique debiasing techniques that can penalize for producing unfairness, okay. So you have to collect more training data. That is why whenever you are working on machine learning project, it is advisable to collect more training data. So once you have a large number of training data, your system is likely to default, your system is likely to give you any biases, okay. They will give you less the biased result. So that is why it is always advisable to collect more training data, because once you have a huge number of training data, you will have better the models and less biased the results. So how you are going to address the biases? So first, if let's say you are developing AI systems or AI solutions, if you are using any black box model, for example, if you are using artificial neural network, any generative AI techniques, so in that case, you have to explain. So better not to use the black box model, because if you are using a black box model, the first one, the black box model, the black box model, if you are using, so it will be your responsibility to explain. So it's better not to use the black box. If it is required, then use it and then go for explainable AI. Then comes accountability. Developers, data scientists, engineers, companies and organization and users. So they must be accountable if they are using any the black box techniques, okay. Monitoring the data drift, concept drift, impact human in the loop, and whenever you are collecting a data, you have to check how that person is biased if they are collecting a sample, because if a person is biased, obviously your training data will be biased. So majority of the time you will see your AI system is not bringing data, the bias result by itself. It is due to the humans who are training that AI systems. Ultimately, we humans are training the AI systems. So you have to check the human in the loop who are collecting the samples. Okay. So that is why it is advisable to bring a diverse group. Okay. So that you can mitigate the bias. Okay. Then education, and let's say if you are developing AI models, so obviously the educated people are there or not, or you are developing the AI solutions for everyone or only for educated one. Okay, you have to just address that. Human centric development, what are model tasks that could help us with this problem, what are the applications of this model. So you have to be sure that the kind of task that AI system is going to do for you, privacy and security, and informed consent, data persistence, and re, uh, repurposing, regulatory compliance. So if you see this one, so whenever you are collecting a data, you must take consent, okay, and the persistence of the data, and regulatory compliance means whether your data is are passed through the GDPR regulation or not. They are fitting into the GDPR regulation or not, because whenever you are using AI or black box model, you have to follow the GDPR regulations, okay, of this European government. So the GDPR regulation is very much important to bring the privacy and security, okay. And the ethics policy, all organizations that build AI should have an ethics policy, because how ethical your AI systems are, and that is more important. Whether you have used some unethical practices to train your data, so that is something which you have to take care of to reduce the biases, because there are many ethicists and they work on this AI systems development, because they also try to check whether they have followed the the particular ethics or not, because whenever you are designing any AI systems, ethics plays an important role, privacy, security. So these are the something which you have to take care. Okay. So these are the some way of addressing the bias. So this is all from my side, and you will see in the next class some how you can say the performance matrices you can calculate. So in that class you will see. So here I have only addressed you the biasness and the confusion matrix, because it's very much important. Okay. So thank you so much. Arif, are you there?
Yes, sir.